Hello everyone, welcome to this series of lectures on database systems. In this video, we will see how data definition language provides the mechanisms for integrity enhancement. So there are certain features through which data integrity can be maintained and enhanced. First of all is the required data. So for example, certain columns may require that they cannot be left without value. So it means there must be some value in these columns. Like an organization must require that if an employee is added, if the record of an employee is added, there must be a name. So there cannot be any employee without name. So this required data feature can be easily accommodated in the database, and this ISO standard provides a not null column specifier. So any column can be specified with this not null constraint, and then this constraint actually prohibits any record that is added without any value for this column. So whenever a column is specified with this not null constraint, so the database system will reject any attempt when the record is added and the column value for this column is null. So if null is specified, then the system actually can accept the record where there is no value for this record. So the default for the ISO standard is that the column this can be null. So this constraint is null by default if not null is not specified. So let's take an example. There is a designation attribute or a designation column, and we are defining it like this. So designation varchar 10. So its data type is varchar, and the length of the characters is 10. And then this is specified as not null. So it means whenever a row is added for this table, and then this designation, there is no value for this designation, the system will not allow to add that row. So the record cannot be added until and unless the value for this column is provided. So the above declaration specifies that the column designation cannot be null. So this is the not null is something that is used to require the data for a particular column. So this is one of the integrity enhancement feature that the data definition language provides. Another integrity enhancement feature is domain constraints. So we already know that domain is actually the set of legal values that a column can be assigned. So taking the example of a gender column in a staff table, for example, so it can either be M or F, M for male, F for female. So actually the domain of this column is these two values. So the gender can only be assigned value M or F. No other value can be assigned to this. Note that this staff table has a single character string consisting of either M or F. So here the ISO standard provides the check clause to accommodate this domain constraints. So let's take an example. This is the format where we can assign the class to the column. So check is a keyword, and then there is a search condition. So this search condition, if it is true, then a value is assigned. If it is false, the value cannot be assigned. So the column constraint check class can reference only the column being defined. So this is something we will see in the example. So whenever a column constraint is defined, the check class can only reference the column that is being actually defined. So therefore, the column gender can be specified like this. So this is gender, the name of the column, and the data type of this column is char, and you see there is no length, so there is one character length by default. And this is specified as not null, so it means there must be a valid value for this column. And then there is this constraint which says that there is a check mechanism that says that gender can only have these two values. So whenever a value is assigned, this check ensures that this gender value is either bit M or F. So no other value can be accepted. So this is the this check clause is something that actually provides the domain constraint for a column. And then we have some other entity integrity enhancement features. So entity integrity, we already know that this is actually supported with a primary key. So ISO standard supports entity integrity with primary key clause. So what it means that whenever some table has a primary key for a column, so for example a column is set as a primary key, so the table must contain a unique value. So there are two constraints. Whenever a column is a primary key, so it must contain a unique value. So across all the rows, its value should be unique, so no duplicate actually is allowed. And then this should also be non-null. It means that it cannot be not null. So there must be a value for each row. Of course, we cannot check uniqueness if this is left as null. So both create and alter key statements provide the mechanism to specify the primary key. So this is the format, or say an example, whenever we say this primary key, and then in the brackets we provide the column name. So this property number is actually the primary key for certain table. There is also possibility to combine two or more columns together to form a composite primary key. So for example, this combination, this mechanism provides the combination of multiple columns to be part of the primary key. So there is an example. So we can say that, for example, client number and property number together should be the primary key. So we can specify it like this, primary key, and then in the parenthesis we provide the comma separated list of columns that should be part of the primary key. So in this example, client number and property number, these both columns together form the primary key. So it means there is a possibility that client number can have the same repeated values, but there should be a unique combination of these columns. So the composite values of these columns together should be unique. So we will see this in more examples later. And one thing to note is that this primary key class can only appear once in a table. So a table can only have one primary key, and that can be only one. So this clause must appear only once in a table. So however, it is also possible to ensure the uniqueness for alternate keys or other columns. So whenever we want to ensure that columns other than the primary key, they must have the unique values for them. Then there is a other keyword that is unique, and this will ensure that the value for the other column, which is not the primary key, their values are actually unique. Note, however, that whenever a column appears in the unique clause, it must be as not null. It should be declared as not null. So in principle, SQL will reject any insert or update operations that will attempt to create a duplicate value for within each candidate key, and this candidate key is actually the unique columns with the unique attribute. So that is the primary key or the alternate key. Of course, the primary key column actually says that the values should be unique and not null, and then the columns defined in the unique class, they are alternate key and they should also be unique per se. So one of the entity integrity one of the integrity enhancement feature is entity integrity, and then we have another enhancement feature, that is referential integrity. So as we know, this referential integrity is actually concerned with the foreign key column. So the column or set of columns which are defined as foreign key, so this actually links one column in one table to the other column in another table, or perhaps to the same table. So what it means by the referential integrity is that if the foreign key contains a value, so if there is a column which is actually the foreign key, and if it contains a value, then that value must come actually from the existing values in the parent table. So the parent table must have those one of those values. Otherwise, if there is no valid row in the parent table, it must be null. So the ISO standard provides the foreign key clause, which is used both in create and alter table statements, which can be used to define the foreign key. For example, if we can define the foreign key branch number so one table has a branch number column, and then we are specifying this branch number as foreign key. So this foreign key is the keyword, and this branch number is the name of the column that we want to specify the foreign key, and then this references actually the keyword, and after this references there must be the name of the parent table. So branch is the parent table. So there are other concerns with primary key, foreign key. To understand this, first let's to be clear that what it means. So we assume that there is a staff table and it has a column branch number, and this in this staff table, this branch number is foreign key to the branch number column in the branch table. So we have a branch table that contains information of the branches, and then we have the staff table that contains the details of the staff, and each staff actually works in a certain branch. So this branch number in a staff table points to the branch number in the branch. So whenever we have a foreign key, there is a concern of what happens when we update or delete some row in the parent table. As an example, say what happens when a branch is deleted. So say the row in a branch table is deleted, and there are some employees that are working in that branch. So what happens for them? So actually the update and delete operation, there can be an associated clause with them on update and on delete. What happens on update and what happens on delete. So the SQL provides 4 possibilities. What happens to the rows in the child table when the row in the parent table is deleted. One is cascade. This operation says that whenever the row in a parent table is deleted, then the all matching rows in the child table are also deleted. And because these deleted rows in the child table can also be the candidate key for another foreign key, so they also cause the deletion of the rows in another table. So these foreign key rules for these tables are triggered only when the delete operation is performed, and they happen in cascading manner. So the parent table row is deleted, then the child then the rows in the child table are deleted, and if this child table is the parent table for an other child table, then the other child table also happens to delete all those rows. So to understand this cascading operation, let's take an example. So say assume that the company has a policy that whenever a branch is closed, it means the branch is deleted, all the employees working in that branch are also sacked, are removed. So they are also sacked from the employment. So then for this condition, we can say we can define the branch number foreign key as follows. So it says that foreign key, which is the branch number, and this reference is the branch table, and on delete cascade. So it says that whenever a branch row is deleted, all the matching rows in the staff table with this branch number are also deleted. So another option that SQL provides is set null. So what happens to the set null is that whenever a row in the parent table is deleted, all the matching rows in the child table having the foreign key value are set to null value. So this option is only valid when foreign key columns do not have the not null qualifier. Otherwise, this not null constant will not allow to be specified null. So let's take an example how this set null works. So for example, the policy of the organization may be that whenever a branch is closed, all the employees working in that branch are temporarily assigned to no branch. So there is no branch assigned to them for the employees whenever they are working in a certain branch, and then that branch is closed. It means it is deleted from the database. So in that case, we can define the foreign key as follows. So foreign key branch number column, the reference is branch table, on delete set null. So when a branch is deleted from a branch table, all the employees working in that branch, they are assigned null to the branch number. Third possibility that we have is set default. What it means that whenever a row from the parent table is deleted, then the foreign key column in the child table, they are specified the default value. It means their columns are assigned the default value which is set. And this option of course is only valid for the foreign key columns that have a default specified. If a column has specified no default value, then this cannot be applied. So let's again take an example. So we have an organization and its policy is that whenever a new recruited employee is assigned to main branch, okay, so this statement actually says that when other organization's policy is that whenever a new employee is recruited, it means the row for the staff is actually added in the staff table. Then the employee number, the branch number for that employee is for the main branch because it is assigned to the main branch. So actually this is actually the default value for the branch number. And then also the company's policy is that whenever a branch is closed, then all the employees that are working in that branch are assigned to the main branch. So we can define the foreign key for this scenario. The scenario is that the organization's default policy is that whenever an employee row is added or a staff row is added, the branch number is actually assigned for the default branch number is assigned of the main branch. And then whenever a branch is closed, all the employees working in that branch are assigned to the main branch. So we say that this branch number is a foreign key, and then this reference is branch table, that is the parent table. And on delete, we say that set default. It is actually default. So it says on delete set default. So its value is set to be to the main branch. So what it says, when a branch is deleted from the branch table, all the employees working in the branch are assigned the branch number of the main branch. That is the default value. And final and the fourth option that we have, what happens when a row in a parent table is deleted, we have the option of no action. And this no action means reject any operation of reject any delete operation on the parent table, because there are certain certain rows in the child table that refer to this row in the parent table. So it says that the delete operation is not permissible in parent table, and actually this is the default setting if we omit on delete rule or say on update rule. To understand this, let's have another example. So now the policy of the branch is that a branch cannot be closed. It means its record cannot be deleted until a single employee is working in that branch. So for the organization to close this branch, it must actually transfer the employees working on that branch to another branch and then close this branch. So we can specify this because this is the default behavior, so we do not specify any on delete clause here. So it means whenever an attempt is made to delete the branch from the branch table and there exists at least one employee working in that branch, then the branch cannot be deleted. So to summarize what happens when a record in a parent table is updated or deleted. So we have four options. One is cascade. It says that delete all the rows in the child table also when a row in the parent table is deleted. We have the option of set null. It says that the column values for the column in the child row should be set to null when a parent table row is deleted. We have another option of set default. It says that then assign the default value to the column in the child table when a parent table row is deleted. And finally, one is the no action. It says that do not allow to delete the row in the parent table at all. So finally, SQL also supports all these operations for the update operation also. And then also you can see how data integrity can be ensured in the Oracle database. So thank you for watching this video and please keep watching.